Hello everyone, welcome on our YouTube channel Physics Made Easy Kota. This is a second part of the chapter electromagnetic induction. In this part we are going to study about the motional EMF, eddy currents, its advantages, its some disadvantages, and also the most important, what is a Fleming right hand rule. So firstly we are going to learn about the Fleming right hand rule. So for the Fleming right hand rule, you can observe in the given diagram that in this we are going to understand about the direction of the induced EMF with the help of our right hand. Like if we stretch the thumb and the first two fingers of our right hand such that these three are mutually perpendicular to each other, then the forefinger or the index finger points in the direction of magnetic field, thumbs give the direction of the motion of the conductor, and the central finger points in the direction of the current induced in the conductor. Now we are going to understand about the motional electromotive force, which is also known as the motional EMF. This is the induced EMF which produced due to the motion of a conductor when it moves in a uniform magnetic field. So if you check the diagram, there is a loop PQRS. In this loop, the arm RS is movable and it can move on the PS and the QR without any friction, and we assume that it moves with the velocity V in a uniform magnetic field. Here the uniform magnetic field is perpendicular to the plane of the paper, or you can say that it is directed into the paper, and therefore the symbol X is used for it. The magnetic flux we know and write down its formula as the equation number 1. Here area can be changed by putting the value Lx, that is by using the concept area is equal to length into breadth. This equation number 1 changes with time, that is when arm RS moves to the left side with velocity V, area enclosed by the loop goes on decreases. Then we can use the Faraday law to calculate the induced EMF, and a negative sign is produced, or we can say that there is a negative sign in the equation number 2. Since S decreases with time, so minus of dx divided by dt is taken as a velocity v with a positive sign, because here the negative sign shows that the x, that is the distance, keep on decreasing with time. So just to replace the data in the equation number 2 with the symbol V, and we have the equation number 3, that is the induced EMF is equal to BLV. So from the expression we can see that motional EMF depend upon the different factors. It depend upon the length of the conductor, speed of the conductor, magnitude of the magnetic field acting perpendicular to the length of the conductor. Now apply the Ohm's law by taking R as the symbol for the resistance of the closed circuit. Here I is the induced current, then simple by using the Ohm's law we have the expression epsilon divided by R. Put the value of the epsilon, that is the value of the motional electromotive force, and get it divided by the R. Then we have the equation number 4. To find the direction of this induced EMF or a current, we can take the help of the Fleming right hand rule, and from that we can have the value of the induced current in this loop in the clockwise direction. Now the motional EMF in case of a rotating coil. For the rotating coil, let us assume the certain things, that is capital N be the number of the turns, capital A be the area of the coil, and let this coil is rotated with the uniform angular velocity omega in a uniform magnetic field, and this magnetic field is perpendicular to the axis of the coil. Then the motional EMF set up in the ends of the coil is given by the equation, and this equation in which we have the value of the epsilon naught by replacing the value NBA into omega. This epsilon naught is known as the peak value of induced current. both the direction and the magnitude of the induced EMF change regularly with time, and this expression represents the alternating EMF, that is a sinusoidally varying EMF. Eddy currents are useful in various aspects, like they are used in the various things in the case of the electric brake, speedometer, and the question is how these are formed. Actually, these are the induced current, and they induced in the solid metallic containers whenever the magnetic flux passes through them changes, and these currents flow in the form of the irregular shaped loop throughout the container. And here Lenz law is very useful to find the direction of the currents. Eddy current also cause the unnecessary heating and the wastage of the power, which are the disadvantages of the eddy current. So now we are going to discuss the various advantages or how the eddy currents are useful. The number one, as the magnetic braking in trains. The strong electromagnets are placed above the rails in some electrically powered trains. When these electromagnets are activated, eddy currents induced in the rails oppose the motion of the train. As there are no mechanical leakage, so the braking system is very smooth. The second is electromagnetic damping. Certain galvanometers have a fixed core made of non-magnetic metallic material. When the coil oscillates, the eddy currents generated in the core oppose the motion and bring the coil to the rest quickly. The eddy currents are also useful in case of the induction furnace. Induction furnace can be used to produce high temperatures and can be utilized to prepare alloys by melting the constituent metal. A high frequency alternating current is required to pass through a coil which surrounds the metal to be melted. Then eddy currents generate in the metal, produce high temperature which is sufficient to melt it. It's another use in the electric power meters. The shiny metal disc in the electric power meter rotates due to the eddy current. So this is useful here. Electric currents are induced in the disc by magnetic field produced by sinusoidally varying current in the coil. Now here are few disadvantages, like there is always the leakage of the magnetic flux because of the production of the eddy currents, and also there is extreme heating of metallic cores of electric motor, transformer or other devices of such a kind. To avoid the extreme heating, the metallic sheets are kept in the form of a very thin sheet that are electrically insulated. The cores are insulated with an insulating material to avoid the transfer of heat in its surrounding. Such cores are called as a laminated core.